Okay, question 11, part A. Here we've got parametric equations x equals cos t and y equals sine squared 2t. T is specifically between 0 and pi. Okay, not 0 to 2 pi, just 0 to pi. That's very important. Now, we're asked in part A to state the greatest and least value of x and then the greatest and least value of y. So what's useful here is to get an idea of what the graphs would look like. So for cos t, we should know that it starts at 1 and then sort of goes down there. And because we're only dealing with 0 to pi, then it would stop there at -1. Which is a pi, equivalent of 180 degrees. Okay, so there quite clearly the greatest output then is 1 when t is 0, and the least value there is -1 when t is pi. Okay. Now, part 2. The greatest and least value for sine squared 2t. What I've drawn here is the graph of y equals sine 2t, not sine squared, sine 2t, which is a stretch or a sort of contraction, a stretch with a factor of a half, so it's been squashed by a factor of a half, the sine curve, hence you get a full period of the sine curve in just pi radian along the x-axis there, well, the t-axis as it is, sorry. Okay, so that's my y equals sine 2t curve. Now the maximum of that is 1, and when you square 1, so if sine 2t is 1 and you then square it, because we're doing sine squared of course, then we would get 1. The minimum, however, is -1. Now if you square -1, okay, you get 1 as well. But that, we've just said, is probably the maximum value. So the overall minimum value, because any of these negative output values, when you square them, are going to turn positive, the minimum is going to occur when you've actually got a 0 value, because 0 squared stays 0. So the minimum output value here is going to be 0. The minimum value for sine squared of 2t is going to be 0. The maximum value is going to be +1. Okay, part B, we're asked to get the Cartesian equation for x equals cos t, y equals sine squared 2t. Now clearly what we'd ideally like would be y expressed purely in terms of cos t, because then we could simply substitute in x in place of that cos t. So let's work on that first. Now, y equals sine squared 2t, you might think, well, okay, well, what's sine 2t? Sine squared 2t is obviously sine 2t all squared. What is then what is sine 2t? Okay, sine 2t is 2 sine t cos t. Okay, well, that's sort of okay. But then if we, in terms of cos t, there could be replaced with x, but sine t on its own. We're a bit stuck, but then if we use this squaring function though and push that through, then we can have 4 sine squared t cos squared t. And now of course once we've got a sine squared t, we can replace that with 1 minus cos squared t, copy down that cos squared t, and now everything is in terms of cos t. So where we've got cos squared t, we can now replace it with x squared there and x squared there. Okay, bit of tidying up to do. Usually we would have that x squared earlier in the expression, and there we go. Okay, final part of question 11 then. We're asked here to find the x and the y-intercepts, and in part B we just finished off by finding the Cartesian equation, which is y equals 4x squared brackets 1 minus x squared. Now if we factorize this further, we get 4x squared, and then difference of two squares here is 1 minus x bracket 1 plus x. Okay, and then when we can see if y equals 0, then we get 0 equals 4x squared 1 minus x 1 plus x. Okay, given that x could be 0, that x could be 1, that x could be minus 1. Okay. Now, the fact that x equals 0 has come from y equaling 0 suggests that whenever x equals 0, y is 0 as well. If you want to double check that, by all means substitute in x equals 0 back in here, and you get 4 times 0 squared, there we go, 1 minus 0, 1 plus 0, ultimately that's going to be 0. So that's the same point we just worked out earlier there. So our x and y intercepts then are going to be, in order from left to right, we've got minus 1, 0, 0, 0 in the middle, and then 1, 0 on the right. There we go.